big part of math and the mathematical side of physics, finance, etc., applied math, is looking for relationships between quantities, right? The formula at the top here, for example, gives the relationship between the time traveled and the distance traveled by an object moving at a constant 65 miles per hour. Now, in mathematics, right, a relationship between that can be described using a formula is called a functional relationship. And what I have down here, right on the second line, this is the same relationship expressed using what's called the function notation, right? And it's kind of trying to make explicit that what we're looking at here is a function. Now, the first thing you need to be aware of, because students often have some trouble with this, the parentheses on the left-hand side do not mean multiply. You are not multiplying d and t. You cannot divide both sides by t and cancel them on the left. You cannot divide both sides by t and cancel them on the left. The way this is read, right? I would read this d of t. That d of t on the left-hand side is one quantity. It's indivisible. You can't split it up. You can't cancel bits and pieces of it. All right? Now, so what are these parts? Well, this d here, this is, you can think of that as the name of the function or a label for the function. Usually, if we're talking about a physical situation like this, where it represents the distance, I'll use a letter that kind of corresponds to what it represents, kind of helps us to remember what it's about. And this list here inside the parentheses is a list of 1. These are the variables that are used in the function. All right, so let's look at an example. All right, I've got a function here, f of x equals x squared plus 2x minus 1. And what I want to know is, what is f of 3? All right, so let me write that underneath here, f of 3. You notice what happened here on this left-hand side. The x got replaced by a 3. Well, to evaluate this, I am literally just going to do exactly the same thing on the right-hand side. I'm going to replace all of the x's over here with 3's. And then just evaluate this, right? This is 9 plus 6 is 15, minus 1 is 14. And that's it. That's my answer, right? F of 3 equals 14, and that's where you stop. Do not try to divide both sides by 3. Right? The left-hand side is not f times 3. It's saying, what is f when x equals 3? Right? And there is no way just to break that up, reduce it, simplify it, or anything. So we're going to leave that left side alone. All right, so we've got another example here. Right? We're going to start with a new function. F of x equals x squared minus 3x. And my question is, what is f of x plus 1? Well, this is a little different, right? Because I put an expression in there instead of a number, but that's fine. We're going to do exactly the same thing. On the left side, x got replaced with x plus 1. So I'm going to do the same thing on the right side. And now I just have to simplify it. That's x squared plus 2x plus 1 minus 3x minus 3. And we can combine some like terms. This is x squared minus x minus 2. And that's it. That is what f of x plus 1 equals. All right, so at this point, you might be asking, well, what's the point of having this x over here on the left-hand side? I can see what the variable is. Just look at the formula, right? The only letters over there are x's. That must be what the variables are. Okay, well, sometimes things are a little busier. For example, here we've got the generic version of a quadratic equation, ax squared plus bx plus c. It's the version that you use when you're talking about the quadratic formula, for example. Not all of the letters on the right-hand side are variables, right? You know, if you're talking about a specific quadratic equation, a, b, and c, they're going to be replaced with numbers. Right? Well, there's a name for those. The a, b, and c here are called parameters, right, to distinguish them from variables. And on the left-hand side here, the only thing we have on the list is the variables. So now if you weren't familiar with the quadratic equation and didn't kind of already know what the A, B, and C were, that variable list on the left-hand side makes it clear, makes it explicit that it's just the X on the right-hand side and not any of the other letters. All right, so far we've looked at functions of one variable, right? It's X and nothing else. Well, you can make functions that are bigger. For example, my function T here, think of T as being temperature. P is the pressure and V is the volume, and this is one of chemistry's gas laws, right? And again, right, I've got a K over here. This K is a parameter. It's a constant. It's going to depend on the specific gas that you're talking about. So you can see again how having that variable list helps to clarify what the variables are versus what the parameters are. Now, I throw that out there. Some of you may be going on to higher things. You'll see these eventually. For our purposes here in this class, in this series of lectures, we're going to limit ourselves to just functions of a single variable. All right, so now we've seen what functions are. We've seen how they can be represented, graphs, formulas, so forth. And we're familiar with this function notation, right? The way we can talk about the value of a function in specific values. All right, well, in the next lecture, we're going to look more deeply at the domain of a function. We're going to look at some specific examples, and we're going to see how we can go from just looking at a formula to determining what the maximum possible domain of a function is.